Hello everyone. Welcome to the final judging round of the recently concluded KJC Hack 6.0. It was a 24-hour event where the participants from all over India competed to make innovative solutions to real-world problems. It was conducted in both offline and the online mode, and we were overwhelmed by the response from the teams. Congratulations to the top 10 teams that were selected yesterday. Each team is going to present their project to the industry professionals who will be judging them on various parameters. We have our judges Harshan Amandeep from ShareChat, Vatsal Kanakia from 100xVC. We have Raj Dhiravani from Riddle. Before we start with the presentations, I would like to invite the judges to give a small introduction about themselves.
You want to go first?
Uh, sure. So, hi everyone. Thank you so much for having me to the KJSC CodeCell team. I'm Vatsal. I'm principal and CTO here at 100xBC. We're an early stage venture fund investing the first check in startups from idea stage and up. So I'm very excited to be here and learn about what teams at this hackathon have built. Fun fact: I was a member of CodeCell about 6 years ago now, and one of the first members of the first hackathon team. So I'm very excited to see how it's grown and to see so many people building amazing stuff. And I look forward to hearing you all pitch to us.
Hey, this is Harshal here. I work as a senior manager at ShareChat. I mostly look at Moj and a couple of other horizontal teams, including platform, infrastructure, security, etc. Um, we've been working with a lot, like we've been having a lot of interns at ShareChat in the past few years, and we've been amazed at the quality of interns that we've been able to attract. It always surprises me how the world has changed. Like probably when I graduated 10, 12 years back, in fact there was no internship concept at all. Uh, Things are very different now, and it's a really exciting place to be. Uh, I thought it'll be a good opportunity to see what's happening around. Yeah.
Yeah, can you all hear me? Hello. Yeah, yeah. Hi, good evening, everyone. Riddle is a startup incubator. We have incubated more than 140 startups in last 10 years, and 54 of our startups have raised funds throughout various programs like Nidhi Triple S, Nidhi Prayas, and external investors. So the goal is to support as many entrepreneurs as possible and support the existing startups with the interns and good coders. So looking forward to hear all the techs, all the projects that are part of this hackathon, and looking forward to support them if they want to go ahead and create a startup of their own, or else if they want to work in an exciting startups, we are happy to provide you that opportunity as well.
Okay, hello. Now Pip Install team is over here and they'll be presenting. So over to you, team Pip Install.
I'll just share my screen. Uh-huh. Okay, I hope my screen is visible. A very warm welcome to all of you, and thank you, CodeCell, for providing us with the opportunity. Our team name is Pip Install, and the project that we are implementing is basically Investor Share. So in India, real estate is one of the most sought after asset for investments. The real estate consists of various categories. That is the residential apartments, the commercial properties. So inside commercial properties, we have two segments. That is the warehouse segment and the office property. So in India, majority of the investments are mostly limited only to residential properties, even though they cost around 1 to 1.5 crores average. So why exactly people are not able to invest in warehouses or office properties, even though the returns are very much higher as compared to residential properties, and also they are very much stable as compared to these residential apartments. So the major reason for this is basically the high initial capital for investing in real estate. So, in India, basically, an average warehouse costs around 20 to 25 crores, whereas the residential apartments they cost around only 1 to 2 crores. So, it's that the commercial properties are about 20 to 30 times costly as compared to these residential apartments. So, is there any solution through which we can extend these investment opportunities to greater pool of investors, which could actually prove valuable? So the solution that we are proposing is fractional ownership in real estate. So what exactly happens in this process is the owners of the real estate properties, that is the owners of warehouse or the offices, they who want to sell or dilute their holdings can decide to divide their property into a number of shares and also allot an initial share price for them. So the share price is basically based on the number of the market value upon number of shares. So the retail investors who are interested to buy these shares, they can buy this with a lock-in period of 6 months. So we are building a platform that can connect these property owners to facilitate business and investments in this sector. So the features that we have implemented is registration and verification of documents. So this is for both the users as well as the property owners. The list the property for offering shares, view the listed properties, their details along with visualizations of share prices over a period, buy and sell shares, and view the portfolio. So once the user who is basically using our website has the flow is like this. So after he logs in, he gets a view of all the properties that have been listed. That is the properties who want to offer a share of their properties, and the user can select the property. So once he selects that particular property, he will get a visualization of the price of flow of the price over a period of time. So based on the visualization and analysis, he can basically buy or sell that particular share. And if there is a price match, that is if the buyer buys that buyer quotes the bidding price, he can. And if there is a similar seller with the same price, there will be a price match and the trade will be executed. And that particular trade will be listed in the investor's portfolio. So the tech stack that we basically use is HTML, CSS, Bootstrap, Chart.js for visualizations, and Django for backend. So in future scope, we are basically planning to add a 6 months lock-in period after buying the shares. That is, once the retail investor buys the particular share, up to a period of 6 months, he can't he can't sell that particular share. So basically, the main reason for this is to avoid short selling and manipulation of the price share. And after placing the buy order, if the trade is not executed within 1 hour, he gets a chance to cancel or modify his order. So after and also a KYC of the registered users and the property owners, since the transactions are worth millions, we need to make sure that the registered users and property owners are authentic. And the last feature is basically the integration with payment gateway, where the user can actually from his bank account he can add into the wallet that we provide for execution of the trades. And thank you. Now we will provide with the live demo of the website.
I'll show you the live demo of the demo. Is my screen visible?
Yes.
Yeah. So this is the login page of our website. So for now we have just use it for admin only. So let's say if I log in with my credential as admin, then once you sign in, now after sign in, you will see all the different properties which are listed. So for now we have divided into three categories: the residential apartments, the office properties, and the warehouses. And for now, all the warehouses which you are seeing here are coming randomly, but this can be improved in the future using some ML models to recommend based on the user experience.
So for example, if I just want to see all the listed properties now with respect to the warehouse, I just can just say click on the see all option, and now you will see all the properties that are listed under the warehouse category. Okay, so now let's come back. So there is a tab of investments. So in the investment, you will basically see all the investments which you have made. For now, as an admin user, we have already invested in the Loda property. So in this section, you will see your purchase price, the purchase date, and the current price, and the total profit or the loss which you are risking. So for now, you can see the Loda is at this price. The Loda is at the profit of 100 rupees. So now let's coming to the home page again. So here you can see like different warehouses again. So if I just click on the Loda, you will see the different graph of the Loda over time. So as you see, the current price is 800, and if you just hover over it, you will see how the price changes. And also we have provided by sell section. So now let's say if I come back here, and again if I select the property, let's say embassy. Now embassy, again you can see the price is changing over the time. Now here you have two options. One is to buy and another one is to sell. Now, let's say if I want to buy one share of embassy at the price of, let's say, 30,000. So now what happens in the backend, that whenever I place this order, it checks with if there is, it first sorts the orders with respect to the prices in the descending order, and then it checks whether or not if there is the same buyer at the similar price. So for example, if I place the order for 30,000, for now in the backend we have already added one user with a who is selling this embassy share at the price of 32,000. So now after some time, after same let's say at the same price, yeah, at the backend we have already added at the 30,000, which is share. Okay. Okay. So let's say, just a second. Yeah. So for now, we have already added one user at the backend who is selling at the 30,000 rupees price share. So if I just refresh again, okay, let's hit buy again. So let's say 30,000 and buy. Okay. Okay. For now, there is some error. So okay, let's try to use some another property. Let's say we try with Loda. Okay, so for now, Loda is a price of 1. So let's say if I hit the price for, let's say, 1,000 rupees. So that is, I want to buy a Loda chair at the price of 1,000 rupees. Now what happens in the background is that it will basically check who's selling at the price of 1,000 rupees, and if there is a match, it will basically match the price, and it will say the our price is executed. So now let's say if I hit the again buy again, and now you can see the our order is executed, and the price of the share which we have is 1,000. Now let's say if I want to sell this share again at the same price, or let's say some price change, let's say 1,100 price. So now in the backend, what we will be having is we will be having another user. We will be having a similar price of the Loda. It's around 1,100, since we have already used 1,000 here, 100. So he'll be basically buying our share. So when I click on the sell button now, you'll see the price has been updated to 1,100. So which means that basically the order which we had placed has been executed, and the price of the share also has been changed. So so that's it for our website, that is investor share. So thank you. Thank you.
Hey, thanks, team.
Pip Install team.
Sorry, may I ask questions? So, thanks, team. Pretty cool what you guys have built. I mean, from an idea perspective, for sure. So, what are the kind of, I see it's like a very, I mean, looks like a regular CRUD app, to me. What have we built on top of it, or any unique features you've thought of which kind of are hotk or are beyond the regular kind of CRUD functions?
Okay, so basically what we are planning to implement is like a fraction investment platform. So yeah, these are the properties like we have implemented, but we are also planning to implement a time frame. Like as you know, in Bombay Stock Exchange or National Stock Exchange, you get a period of if the trade doesn't execute in the market hours, it gets automatically cancelled. So what we are basically planning is also a similar set. They were like the trade will be running in the background. Like if there isn't any set for a particular buyer, the trade will be running in the background, and if the trade doesn't get executed, then it will automatically get cancelled within a period of an hour. So yeah, this is one of the feature. And secondly, we're also planning to add a 6 months lock-in period. That is, once you buy the, let's suppose this Somaya share for 25,000 rupees. So after you buy that particular share, for a next period of for a period of 6 months, the sell button will be disabled completely. So the main reason is because to avoid the manipulation of that particular share price, and the user doesn't have to, and basically the user can sell that. And so this is one of the feature. And also we are want to implement the KYC process also, because this since the users or the property users, since this is a real estate market, there's a high chance that like a black money can be involved in this. So for verification of the verification, we are planning to add this KYC methodology also. And on top of that, the wallet which we haven't implemented as of now. So the once if the user wants to buy that particular share, the user has to spend that money from our wallet only. He can't directly he can transfer the money from his bank account to our wallet, and can spend the money from our wallet. So these are some features as of now that we have thought of. And yeah, so and also the user can also list his property. Like if he owns a warehouse that he wants to dilute his ownership, or completely sell off, then he can also implement he can list his property, and all the various features such as the property name, the tenant that has been tenant, etc. All these will be mentioned in that particular uh, for that particular property.
Sure. No, thanks so much, team. I'm done.
Hey, did you think of search by geography, search by location?
No, not as of now actually. Because of the time constraints, we couldn't completely implement that particular search bar. But sure, we can actually implement based on the geography. Like if he wants to invest in US properties or UK properties, we can implement that particular feature. Like we are taking the location address of that particular property in our database, also in our database. But yeah, as of now, we didn't implement that. And also yeah, we can also basically we are planning to build a recommendation system also. Like as I said, like because of the time constraints, we couldn't implement that. So that particular recommendation system will basically work on his history. So let's suppose the user is implementing, suppose the user is making a lot of investments in a UK properties. So the next that's our recommendation system will basically it will basically recommend the warehouses or office properties pertaining to UK. And let's suppose the investors are trying to invest in tenant in warehouses whose tenant is Amazon. So the recommendation system can recommend based on this, based on the tenant. So yeah.
And did you think of real fractional ownership? Because right now you're still giving like one or two shares. Can I have half a share or quarter of a share?
Yes, no, not. I didn't actually think of that fraction of a fractional share. So as of now, we can invest only in whole number, in integer numbers. That is only one or share or two share. Yes, but we can also implement that. Like it basically then amounts to the amount that he wants to invest, and not based on the quantity. If there's a 25,000 share, if he wants to invest in only 2,500 rupees, then yeah, like 1/10 of a share will be reduced into his account. So yeah, we can implement that also. But uh, okay, Raj Dilwani sir has asked the questions of what all data points you are covering of a property to help us. Okay, so the data points that we are covering for a property is first is a property owner name, basically the market value capital. So the market, So basically, we are so the property name, the market valuation of that particular property, the tenant, the lock-in period, then the lock-in period of the tenant, the lease period of the tenant. So yeah, as you can see, we will just show in the admin also. So yeah, these are the properties that so the area square kilometer, then listing price, the market price, the owner, tenant rent, lock-in period, dilution, that is how much the owner is ready to sell, and approval status also. So approval status, the main reason that put is basically once the owner lists his property, the property won't be directly visible to the retail investors. That will only remain in backend, and we will be verifying if the details are legitimate. So let's suppose if the market value of that particular property is only 3 crores, but if the owner is providing shares based on the market value of 5 crores, then we will basically recommend him that based on so and so parameters by government regulations and all that, you have to reduce the market value of your particular share. And so yeah, and also we are taking the category that if the category is a warehouse or residential or office property like that.
The buyers.
Hello. Okay, okay. Because of time constraint, we could only show the like the graph, the price change, and so I'll just show that the graph, the change of the price, and the current share price. But we are just planning to like we will be fetching all those details and showing all the details to the buyers also to maintain transparency. Like only just like the I accept the approval status, because if the property is basically approved, then only the particular property will be listed. But we are also, and also based on the we are also planning to add the charts like the like property of like profits of the particular owner if the owner has any other warehouses and all that. So okay, Raj has left. So yeah, all the details will be mentioned, but yeah, because of the time constraints, like based on because to implement the buy and sell algorithms and all that, we couldn't display all those features, but all the data points will be visible, made visible. Thank you.
Okay, thank you so much, Pip Install, and thank you so much, judges, for 3 questions. So now we will have the discussion right now. Pip Install team, you can leave the meet. Thank you so much.
Okay.
Yeah, our teammate is here.
Hello everyone, this is team Breaking Codes now we have with us. Now Breaking Codes team, we will be giving 10 minutes. I'll be giving a 5-minute reminder and a 1-minute reminder in the message. Over to you, team Breaking Codes. All the best.
Thank you. Right, so is my screen visible?
Yes.
Hello? Yeah, it is, right? Right, so let's get started. So what have we built over here, first of all? So in our average day-to-day life, we consume a lot of content from YouTube. But more often than not, what happens is we don't realize if this video was supposed to be watched or not in the first place. And let's suppose I'm watching a car review video, and I come across this particular video wherein I'm only in the motor of the car and not really with how the tire are performing. So what would ideally happen? I would just keep skipping around in the video unless and until I don't find my perfect point, or I'd just randomly skip that particular video. Now, second of all, there's a lot of propaganda that spreads with the YouTube videos, and we are pretty much aware of that. Now, in order to combat these two issues, we've come up with a Chrome extension to help you navigate through YouTube as well as be able to as well as get a granular control over the YouTube videos that you watch. So let's get started. Let's suppose as an average user, I want to see the review for Tesla Model S plate. So I click on this in the search bar, and now I can make use of this extension. And over here itself, I'll get the rankings with respect to what video should I be watching first, what video should I be watching second, and all. So over here, as you can see, there are a lot of videos that I need to process at once. So in order to make the processing more efficient, we've made use of multiprocessing. We made use of multiprocessing in order to parallelly process each of these videos and understand their sentiments. And once we have those things, and obviously we also have a live update that is happening with respect to the status. So we had processing, and now it's been live updated via sockets that we are now analyzing this video. Yeah. So as you can see, we have results with us ready. So we click on one of these videos. Let's say I'm getting the first video that is recommended to me. Let's navigate to this particular video now.
This is the
Right. So I make the extension over here, and now we have a bunch of utility functions over here. So getting started with the top 5 keyword suggestions. Now, what are these top 5 keyword suggestions? Let's suppose a video is completely alien to me. More often than not, what would happen is that I would like to actually see what parts or segments of the video are actually popular amongst users, and what was it that these people or the other users most popularly search for. So this gives me a general consensus about the video and what were the popular sections of those particular videos amongst the people who've already watched it. Now again, this is something that keeps dynamically updating, and this is updated via sockets. So I can click on either of these keywords. Let's say I click on 0 to 60, and I search for this particular keyword. So we'll have the results in a bit. Yeah, so we have the results here. I can click on either of these suggestions, and then I will accordingly be taken to that particular part of the video. Have a look at the address bar that is there over here. So now when I click on this particular recommendation, my address bar changes, and now I have a query parameter of 996 seconds. And as you can see, I have 0 to 60 miles per hour over here. Now moving on to suggested entities. What are these suggested entities? These are the entities that are most famously being referred in the video, and this can help me draw inferences with respect to what I should be watching. Let's suppose I had a Honda and I would like to actually see how Honda is being compared with Tesla. And I can even, in fact, I can even search for multiple entities at once. So I can search for Honda in UK at once, and we'll search for these entities now. Right, so we have the results over here, and as you can see in the first recommendation I have Honda, and in the second recommendation I have UK mentioned. So I now click on Honda. We'll be again redirected to that particular instance of the video.
see that Honda there?
And now it will take it on from here.
So as you can see above here, there is a viewer sentence score that is given of 0.404. So what this basically does is, this is the replacement of the dislike button that the YouTube has removed recently. As the users dislike a video, they do not get a score or the number of dislikes that are there on that particular video. So what we've got to do is, we are using the YouTube data API to retrieve all the comments that are there on this YouTube video. And what we are doing is, we are doing an average, weighted average on those comments and the corresponding likes on those comments to get an aggregate view of what the viewer thinks of this video. And thus we are getting the score of 0.404 that highlights or hashes this blue section, which is greater than 0.2, that shows that the video is being put in a very positive sense towards the user. Now, as we come to the search bar is basically as intuitive as a Google search bar. And here, what the user can do is he can type in a keyword, a set of keywords that are not mentioned in the suggested entities or the top 5 keyword searches. According to his likes, he could just mention some word. Say, for example, this is a car video, so he wants to watch some section of the video naming horsepower. So he can put horsepower and do the search accordingly. What we've done here is we've done video search, and we get again the suggestions from the video to get the top 5 suggestions from the video having horsepower. So if you see again, it will be navigated to that section where horsepower is present. So now we would like to go ahead on the analytics section of the YouTube assistant. What we have done here is first we are analyzing the YouTube transcripts, and we are giving sentiments in 3 categories based on the compound score that we retrieve: positive, negative, and neutral. As you can see in the first graph, this is the analysis of the video transcripts. Then we come down to the video comments. So what we've done here particularly is we've done a sentiment analysis on the video comments and the corresponding likes. Here what we've done is we've also removed sarcasm that are present in these video comments, as well as we've tried to consider that, not removed, we've tried to consider that sarcasm in our analysis. Apart from that, we've also done emoji detection, which our algorithm works very efficiently on these comments. Now we've also tried to remove the propagandist comments or the hatred comments that are being spread on YouTube by categorizing them into these 4 categories as of now. As you can see through the legend, ORG means organization, companies, NORP means nationality, religious or political groups. So what this basically does is it classifies these entities into these sections and shows how much hatred is being spread to these propagandist comments on this YouTube video. Now coming to the next section, which is the Reddit section. What we are doing here is we want to give more information to our users based on the topics that are being discussed in the video. So what we have done is we've also given the subreddit links to our users. They could go on to these subreddit links and have further discussion about these topics. For example, we could go to the Honda subreddit. Here we'll get all the stuff that he wants to know about Honda and how it is relevant to the video that we are showing. Now let's just go ahead with the architecture diagram that we have.
Right, thank you, Ed. So I'll now take you all ahead with the architecture diagram that we have for this thing. So we have 2 architecture diagrams. I'll give an overview of the backend architecture diagram we have with us over here. Right, so we have a few auto-scaling instances that are being set up in auto-scaling mode with CPU utilization as my metric, and we'll be horizontally scaling these instances. These instances are again divided into multiple availability zones. So even if one availability zone is down, I have others for my backup. I have a load balancer that naturally balances the load between them. I have Route 53 that is used for domain name resolution, my front-end interface as it stands over here. So my user accesses the front-end interface, and then my back-end interaction happens by the Route 53 load balancer, auto instances in auto scaling, and we also make use of elastic cache. How do we use elastic cache over here is, as you saw, that we made a particular search. Now, when this particular search was made, what really happened is that, let's suppose another user wanted to make the same sort of search. So in order to make that processing faster and improve the UI UX experience per se, we make use of caching. So we actually hash we cache the result that we have with us over there, and then we accordingly send across the result. So the latency drops down to some milliseconds. So this is our backend architecture per se, and now we'll go to the algorithms, the ML pipeline that we have over here. So as you saw over here, we had a very brilliant USP of video searching. So how did that actually work? We have the transcript with us over there. Whenever you add a particular, say a sentence, we add that particular sentence to the bottom of the transcript. Then those transcripts are taken. We do TF-IDF vectorization. Once we do TF-IDF vectorization, we have the sentences as a vector form. We then consider cosine similarity and return to you the top 5 searches that we have. Same goes with sentiment analysis. Now, with sentiment analysis, we had multiple options. First of all, the data set will never be sufficient for these kind of cases wherein I have bulk of so many YouTube comments being generated day in and day out. But in order to do so, what I had at hand was unsupervised machine learning. We could have actually taken a data set, but that would never have been a proper representative sample of what I wanted to show. So we could have even used on neural networks, but that was again over engineering, and maybe making use of sklearn was also on the cards. But again, making use of NLTK vector lexicon, it allowed us to already use this particular model, so that yeah, that's so. So that we can detect sarcasm, detect emojis, and be able to kind of get an appropriate score rather than just having a sample that is never representative of my actual data set, how that would look like in my population. And yes, to also extend to this thing, our browser, I mean our Chrome extension is browser agnostic. So it works on Google Chrome as well as on Brave as well as on Microsoft Edge as well. Right. So you have this browser extension, you can access it from here. So yeah, this our extension is browser agnostic actually. And apart from them, that's about it. Thank you very much.
This was all built during the hackathon?
Yes.
So thanks for the presentation. The product looks really nice. Keen to understand, was the searches that you showed us, were they cached before and already executed?
No, these are not cached actually.
Because I would presume this would take a lot of processing time, right? I mean, I imagine if you search for a, let's say, iPhone review video, right? Then even like if you scrape the first page, that's about 10-20 videos, which you'll have to kind of then go into, download the videos, or run it through your sentiment analysis, run it through like transcripts through sentiment analysis, then rank. It would take a lot of effort and time, right? And the results were coming fairly quickly.
Sir, so if you want, we could show you on your video if you would like, and we could search whatever keyword you would like us to search in that video. If you would like, we could.
Yeah, why don't you bring up YouTube?
Yeah.
How do you get the transcript?
Yeah.
How do you get the transcript?
We have the YouTube transcript API with us, so we get the transcripts via that thing.
Okay, so you get it ready-made from YouTube.
Yes.
And also the comments.
Yes,
Yeah.
yes.
Yeah, the comments are fetched through the YouTube data API.
Do you process all the comments, or do you take like top 100, top 500 or so?
Top 100 comments are being taken into consideration, and we are also taking consideration of the likes on those comments. Many a time what happens is only the comment is taken into consideration, but the corresponding likes also matter. Many a times if you like certain comment, you wouldn't go and comment the same thing, but instead you would like that comment, and thus we are taking into consideration that comment as well to give a good average score that we are having in our algorithm, the weighted average algorithm. As you said, sir, we could go and search for a video as well.
Yeah, why don't you search for Samsung Galaxy S20 review? S20 review.
This one works?
No, just show me. Can you show me what are the video recommendations first? I'd like to see that. वो तो अभी अच्छा processing में है, right?
Yes.
So it's processing. What we are doing here is we are getting the two scores. One is the sentiment score from the video transcribing, and other is from the comments as well. So what we are doing is when we are giving suggestions here, we are trying to analyze both of these, and here we are using multi-threading. So even though we are using multi-threading, it still takes some time to fetch.
What do you mean by आप बोल रहे थे multi-processing, multi-threading, क्या मतलब है आपका?
Yes, sir. So what we are basically doing is, when I have my data, what I'm doing is I'm splitting it down into, say, a list. I have this particular list, and then I'm making use of multi-processing module to split it amongst my cores that I have in my system, and then accordingly each and every core will run its job, and then results aggregate. Okay, it is being shown to you over here.
Okay. Why are a few videos showing sentiment unmeasurable?
Because they are not having captions in them. So what this basic model works is on English videos only. So when we are having Hindi videos, we are not able to do sentiment analysis on that. We are trying to do that, or we are keeping it as a future scope from here out of the hackathon to analyze it on Hindi videos as well.
Yeah, right. So make it make it multilingual, as in I can search in English, get results back in on a Hindi video. I could perhaps search in English, get back the results in English, or maybe on a regional language video, I could search in English and get those results accordingly. So yeah, make it properly multilingual.
Got it. Go to the MKBHD video and then show me what is being shown in the results inside.
Sure.
So as you see, we have no results for the top 5 keywords here because we haven't, this is not being used by anyone because we made it right now. So there are no top results or the searches that the user have made on this video. This is a brand new video. We've got the suggested entities. And sir, what would you like to search in the search bar, as you said?
Or maybe use the suggested entities.
Yeah, you can try the suggested entities as
camera well. Keyword, can you put camera?
Yeah. So as you see, we've got suggestions for camera. We'll click on that.
A bigger battery, a new camera system.
And over here we are even in fact caching this as well.
So as you see, it comes in 3.852 seconds for the first time. Now when the user searches for the second time, or maybe some other user searches, then it comes down to 0.89 seconds.
So that is where we make use of the Redis cache that we had with us.
Can you show me the analytics for the video?
Sure,
yeah.
Sir. Just a moment.
So this is the score corresponding positive, negative, neutral. Then we've also classified these. As you see, we had given these legend
entity
and
classes.
according entity classes.
Okay, cool. I think I'm done for now. Harshal and Raj.
Hey, what will happen when like millions and billions of videos will be analyzed?
Right.
How does the system scale?
All right. So that is where, to address this particular question, I had shown the system architecture. So this is where my EC2 instances would be doing the computation. This would perhaps not even be EC2 instances. We could make use of spot instances because there's no user data that we are trying to persist per se. So we can have these instances in auto scaling configuration and a load balancer over it. So we can try distributing the load to our different instances in horizontal scaling mechanism and then try to get the results as soon as possible. And then again, all of these systems would require the vCPU options that are there, so the number of cores and threads. So we can choose a particular optimal configuration as such, and then go ahead with it.
And your TF-IDF. So do you store the entire transcript, or do you just store the score?
So basically, what happens is, as long as you use this particular thing, we have the transcript with us. But we don't really need to save anything as such.
Sir, everything is happening on the fly. Nothing is being stored because there will be thousands and crores of video, and our data will be filled by storing these transcripts. So right now, for the purpose of the hackathon, we did not feel the need to store all these things on the database because it would unnecessarily clog up our databases.
Okay. So what do you store in Elastic then?
Yes. So as I showed to you over here, the results that are being fetched from here, this is what gets stored in the Elastic cache. So we have the key as my video ID and a combination of the string as camera and then the result. So we are doing a bit of key manipulation on Redis in order to associate that result with the keyword that you searched for and the video ID that is there.
Okay. In the transcript, right? Like your word is searched in the transcript.
Yes, sir.
So then you need the transcript. And where is it? It's in memory right now.
No, sir. So basically, what happens is when the user clicks on this extension, at that point of time, if you see after this watch, we have this ID. So what we are doing here is we are extracting this ID, and on the fly, as soon as the Chrome extension is accessed, at that point of time itself, we are bringing in the transcripts. And for the time when the user is accessing the Chrome extension for this particular video, we are keeping that transcripts in the class.
So we have it with a session over here.
We have it with the session and we are using it at that time.
Okay. Okay, cool. Thanks.
So, can you show me your GitHub for this?
Sure.
And I'd like to see the commit history quickly.
Sure.
So this is the commit history that we have. And do you want us to jump to the code?
There's only 5 commits.
So what we usually do is, now we are in the 4th year itself. So we divide the work, and as soon as we are done with that work, we try to push it.
So all of us had each different responsibilities. So one of us was assigned to the front end part, one of us was with ML.
Shouldn't there be more commits?
So what basically we've done here is we have been associated with coding committees as well. So what we have that experience to code that particular whole section that we have at a single point, and we just push it across. So if you want, I could.
All of these are actually modular. None of them have dependencies. So like my dependency would not. My commit would not be dependent on my friend's commit. So that is how it works.
Yeah, but it's hard to believe that there were no changes required or there were no bugs.
So if you would like, so what we basically do is, before committing itself, we try whatever code that we are pushing, we try that code is proper, and before pushing it, we test it on our PCs itself, and then after that we push it across.
How will you have your friend's code?
Sorry?
Like how do you test end to end then?
So basically, with end-to-end testing, what is that? There is the APIs that need to be tested. So one of us is responsible for testing APIs, and then accordingly pushes it off. And then uske baad comes with the UI testing that is there. So once we have the APIs ready, we can do the UI testing. So that is how all of us get started with all of these things.
So is everyone testing their own code, or is there one person testing all the code?
No, so what happens is everyone tests their own code before they push it onto GitHub, and then uske baad we do a general testing that is there supposed to be done.
And
so before, as soon as we pull the code, as soon as I pull the code that my friend has, uploaded, we try to test that code, and we only try to make any changes if there are some small bugs or anything, and then we push the complete code that I have coded plus the changes that I have made on my friend's code, and then we push it across. So if you want, we could show you the code itself.
Yeah, that is not an issue.
I mean, have you squashed the commits?
No, we haven't squashed the commits.
Okay. Okay.
So you could look at it. Basically, when we are creating a class, the whole class is a single file. There is no point sharing the file wala part with two people, because there will be then there will be conflicts which we do not want. So as you see, this is the complete file, or this complete class that we have. We don't want then there is one person who is creating the class, that person will complete the complete code. We've had experiences earlier, so now we are very much in sync while we are coding with friends. So it's not much of a big deal.
Okay, I mean, I've never seen perfect code in the first attempt.
So as I said, that if there are some problems or there are some changes that needed to be done. For example, if Josh is committing some code, after that commit, if I am pulling that code and if I see that there are some changes that are required in that code, as well as that there is some code that I need to add, then both of these things I do at the same time. I do not do a commit after changing some code that Josh has done, and do not commit my code separately. So what I usually do is we are having that sync, and in case I have some bug or error that I need to fix, I fix it beforehand before committing together the complete code. So this is how we basically work
So
during our
can
hackathon.
you show me the commit? Like, can you click on 5 commits?
Yeah,
Yeah.
sure.
Yeah, and can you show me the files that have changed for each of the commit?
Fine, not an issue. So this was the first commit that was added with respect to the node backend that we had. So this
Yeah.
was the basic boilerplate that we had to prepare.
Yeah. Okay. Can you go to the next one? Like,
Yeah, sure, not an issue.
can you
So
show me?
once we had the boilerplate prepared, we did the sentiment classification and analysis that was supposed to be done over here. So I had my Pi backend that was there over
Can
here.
you click on backend? Like, can you go back?
Yeah,
So you are saying you've also changed backend, which was committed just before this commit. Correct. So the first commit,
Yeah. So the
yeah.
first commit is the backend. Then we added the sentiment analysis and spy class creation.
So can you show me the second?
yeah,
Oh,
yeah.
Yeah.
So that is what I'm
oh
showing
no,
you.
just show me the diff, like not the entire code.
Just click on the when you no, no, click on the sentiment analysis and spy class creation text. हाँ, वो
Yeah.
diff
Yeah,
दिखाएगा.
Yeah. So have you changed anything in backend over here?
no.
No,
Okay.
sir.
Okay. Go back now. So where can you show me a commit where some person has changed some other person's code?
Sir, I don't think so because I hadn't made any changes. So I don't know if Josh has. So let's just check Josh's code.
आप दो ही devs हो.
हाँ sir, so what basically happened is the other two people had college, had to go to the college, and like one of them was ill. So we two were the people who were coding at this point. So as you see, the code is very basic. Like we are just doing HTML over here. So we actually do not need to change anything because this is just basic HTML. Earlier we tried using React on this, but then what happened is React was very difficult to put up on the build. So then we deleted that code and we went to HTML itself, because as you see, there is this Chrome extension, and on the Chrome extension, to put the complete build that the React creates, it becomes very heavy, and at that point of time, loading also that thing, it becomes very tough. So what we thought of is we would just
I
code in HTML.
understand, but I'm seeing all commits before 2 days, and I'm not seeing any subsequent commits. Like, how do I know if, like, it essentially means that everything just worked in the first attempt,
That is, sir,
or
that
you
is not the
committed.
case. I'll try to explain. So what has happened is if someone had a doubt, we would set up a Google Meet and had his doubt resolved in his commit itself.
But this event started on Saturday, right?
Yeah.
Right.
Which is 2 days ago,
Right.
Yes.
and you committed 2 days ago. So that means your code was over on Saturday.
No,
No,
sir, we had a commit yesterday
we had
itself.
a commit yesterday itself.
Acha. Can you show me the last commit?
Yeah.
Yeah, sure.
We
This is
have
a full
been
file.
working on this for 24 hours. I mean, literally the whole night we have been working on this. We haven't slept for 2 days.
Okay.
Okay. I think we're done for now. Thanks, team. Thanks for your time.
Yeah.
Yeah, thank
Thank
you.
you.
Amazing presentation, guys. Thank you, Teams Breaking Code. Now I request all of you to lead the meet. Online participants, we will be back in a few minutes with our next team. Thank you so much. Welcome Team Elite. Now you'll be presenting in front of the judges. You will be given 10 minutes time to present your ideas and your project. I will give a reminder in the chat for 5 minutes, also for 1 minute. After 10 minutes to wrap up, and then you will be having questions from the judges. Thank you so much and all the best.
Okay, thank you very much. I'll share my screen. So we'll start with our PPT, where they will go.
Thank you, Rudresh, and good evening, everyone. We're Team Elite, and we'd like to present our idea, which is Memepedia, which is unprejudiced, vigilant, virtual meme sharing decentralized NFT platform using IPFS, Filecoin, Polygon, and Solo. The next slide, please. So recently, memes have formed a huge part of the entertainment industry, but we observe that although memes get shared crazily, the creators of those are not benefited much due to lack of ownership privileges. So we've built a decentralized system for meme sharing so that the meme reaches maximum audience, but at every point, the creator maintains the ownership of the content. So following are the objectives we've satisfied, starting with allowing the creator to hold the ownership of the meme, prohibiting it from being plagiarized and restricting extreme content, detecting same and similar memes so that viewers are not bored of these, and also allowing the creator to monetize this content using the NFTs. So now I'd like to ask Rudresh to show you a quick demo of our system.
Yeah, sure. I'll just quickly go to their website. So basically, this is the landing page of our website where I just created a Memepedia, which is a meme NFT platform. Here we are put in some features, and we'll then go to the part where we just mint our NFTs. So currently, we are on the Celo network, as you can see here in the MetaMask. This is Alpha test network. So let's try to put in a meme, just name it, and then choose a file, let's say. And for that, let's say I'm choosing this Drake meme. So now the first thing is that the report has come whether this content is adult content, which is very unlikely from the meme that we uploaded. Whether it's a violence, it is unlikely. If it is racist, same, it is unlikely. And then we have got this memes which are similar to the meme that we have uploaded. So as you can see, we have uploaded the Drake meme. So there were already two Drake memes on the platform, and the similarity is quite high. That is 0.9 with the 0.9 and 0.91 with both the Drake memes. And with the other Pikachu and the other programmer meme, that is low to the point that we can ignore them with the certain thresholds. So let's say we want to upload this meme. That now we're actually creating a NFT for the specific meme, then mint NFT transaction on the Celo network. And till the point that is a transaction is processing, I can actually show you that on the okay, the transaction has been successful, and the the NFT has been minted. So for the example, I could also show you that here there are some memes which have been already minted, like this Drake meme. I'll again choose the same meme. And the report was like the original report that is come with is adult violence or racist meme, and with the same thing, it is also notified that the same image already exists. So it will not let us upload the meme and restrict us from uploading it. And the another thing is that we also wanted to do this on the multi-chain basis. So we are actually deployed it on the Polygon testnet also. And here also we can I'll just give a demo of deploying a meme. Minting the meme on the testnet. So say I have this, and the score for it is like very unlikely adult violence and racist content. So and the similarity of the memes has come. So they are all below the 90% mark. And then we just upload it. Based on the network to network, so the latency might vary. So still, now I have again the transaction on the Polygon testnet. So it will take some time for the processing, and we'll be notified when it is done. Meanwhile, I'll actually show you the transaction. Okay, so success in minting, that meme has been minted. And to see all the memes that actually have been minted by me. So there is a profile section also where you can actually see the memes that we have already minted. And if you just go click on the any of the meme, we are actually directing it to the OpenSea marketplace where we can resell the memes. Let's say for this meme, which is like a 0.0 ether. And ultimately for the same thing we are actually done for the Celo testnet also. If the testnet is Celo here. The page has been refreshed right now. Then we will be directed to the contract that is employed for the same meme. So that was for the demo of basic demo of our project that we built in this hackathon. So I'll continue with the working of this specific project.
Thank you, Rudresh. So as we said, memes are verified for the originality in content and their appropriateness. We have three layers of checks to accomplish this. So the first layer compares the hash of the image with existing hash available in our IPFS metadata. So if an exact match is found, the meme will be discarded as Rudresh showed in the demonstration. So another two layers will be explained by Jay. I'd like to call them.
Thanks a lot, Vaidehi. So the next layer of security, here we talk about the appropriateness of the meme. For the same, we have used the Safe Search API provided by Google, Cloud Vision API. What this API does is it takes in the image as a base 64 string, and then it tells us how very unlikely or very likely. So the scale ranges from very unlikely to very likely. If it has some violence in it, if it has some adult content in it, or if it has some racist content in it. And according to the scale that we have got here, we discard the memes with a degree of very likely. So if it is very likely to have violence in it, we discard it. If it is very likely to have adult content in it, we discard it. Or if it is racist, very likely we discard it. Going on to the next layer. So this is the layer 3. Now this is not actually a security layer. It is kind of you can say a layer where the user can check itself his own meme that he's uploading. Here we have used a VGG19 network. So VGG19 is an advanced convolutional neural network. It is a deep network, and it has a very deep understanding of how images are in terms of shape, colors, and structures. So what we do is for every image that is being minted, an NFT, we take the embeddings of every image and then store it in the IPFS metadata while minting. And then when someone goes to mint a new NFT or a new image, these embeddings are compared. Now, why we are comparing embeddings? Because comparing images will take a lot of time, but embeddings are just a couple of floats which we compare, and then based on the comparison. So for comparison, we use cosine similarity metrics, and based on the similarity score, if a meme has above 90 to 95% similarity, we discard it. And then memes having greater than 50% are shown on the page basically as similar memes, so the user can check if the meme already exists or not. Moving on to the unique selling point, I would like Pashwa to take over.
So now coming on to unique selling point, what are we offering differently? So first, maintenance of ownership due to decentralized platform. So now we want to introduce Indians to a Web3 platform and decentralized platform, so where every creator owns something. Next is no scope for plagiarism. So plagiarism, as told before, we have 3 security checks. So no plagiarism will be possible using our platform. So we'll be respecting creator and its hard work. Next is more scope for unique ideas and content. Unique ideas and content, since memes are very creative, more ideas will come and more content will be shared on the platform. Conversion of memes to NFTs. So as told before, NFTs are an ownership platform. So via ownership, we are providing a kind of respect to the creator, so that they can own a particular, rather than if we would have known who was the Drake meme creator, it would be better. Like, we don't know the creator name, so here the Drake meme creator is owning that NFT, so we know that particular person. Then monetization opportunities for creator, the creator can sell the NFTs and just monetize and can get the royalty. Now coming on to tech stack, we have made 2 blockchains, Polygon and Celo. Filecoin and IPFS is used for decentralized storage. We have used front end React.js and Next.js. And Morales and Tatum are the two APIs where we get the NFT data. Next, last part is Truffle and Solidity. So Truffle is used for deploying our contract and testing, and Solidity is used for writing a smart contract. Next slide. So as a part of future scope, we want to support more media extensions. Right now we are supporting memes. We can also make video NFTs, GIF NFTs, and book NFTs, all kind of video extensions where every content creator will own something. Improvements in the user interface. So this was a hackathon project. So we will try to improve the UI of this project. And last but not the least is a full-fledged social media platform for meme sharing, where we can deploy this platform live and we can support creators and viewers as well. Now you can move on to next this OpenSea collection. So this is, you can refresh the page. So these are the OpenSea collection NFTs. So here you can see all the NFTs minted by a particular creator. So these are the NFTs, and this was the latest NFT which was minted right now, the last one, 7th one. So and you can also set the price for a particular NFT. So first that this NFT is the latest one which was deployed right now. You can the creator can keep a particular price for that NFT and sell that NFT to other users. Yes, you can create an NFT.
So meanwhile, the transaction is getting completed. I would
Yeah.
also like to add that the process which is going on for the plagiarism check and all is completely automated, so it would take very less time to complete. And finally, the NFT is also listed on the OpenSea. So
Yeah, that's it.
thank you. Yeah.
We are open to
That's it.
questions.
So team, thanks for the presentation. So the only reason I would be minting on your platform and not directly on OpenSea is you help me with plagiarism, right? And you help me with figuring out if a meme is appropriate or not.
Yeah, and if similar memes already exist in the market, which like won't be a good idea if you post the same thing again.
On the plagiarism front, I understand you're doing, hash-based checking, right? And so wouldn't it be like when I encoding change kiya, ya fir, I just change one pixel, then the whole hash changes. So that way I can just avoid plagiarism, right?
This is where the layer 3 comes in, where we have used a BGG19 network and the embeddings of every image is being stored in the IPFS metadata. So when you put a new image into the system, it checks with those last embeddings, and if using cosine similarity, we can see if it is more than 95% similar. We have tried it, so we set the threshold to 95.
Why do you use IPFS?
So IPFS, it's a decentralized storage. So rather than minting NFT on a clear, like on a centralized storage, we provide a decentralized storage. And also for any kind of NFT you have to mint, the better is you supply metadata URI, which is stored on IPFS, and then you can easily mint the NFTs.
So a couple questions. Would it not be possible to store the encodings as payload itself with the NFT, with the ERC721 token? And
Yes, we are storing
is,
that as well.
storing
On the first question, we are storing encoding as a metadata as well. We are in that IPFS only as a metadata.
IPFS is different and payload of the coin token itself is different, right?
Yeah, actually, we got a question. Actually, I was asking whether it is possible to store the encoding on the blockchain, right? So actually, we had thought of it, but the thing is that we are actually using the standard ERC721 contract, and for doing the same, we would have to modify it a little bit. So the option we go with using to store it into IPFS only. But considering your point, it is valid.
IPFS में querying कैसे होगा?
Yeah,
wouldn't
so
it be faster to just put it on like a SQL DB or something than make it easier to query?
Yeah, so for the querying, we have used two APIs, Morales and Tatum. For Polygon chain, there is a Morales is a layer which tries to fetch the IPFS, fetch the entries for a particular NFT, and with that we get the query support from them. So basically one API call and you get a particular all metadata for that particular NFT, like image, description, their encodings for that particular which are and along with that we also get image link. So
Yes.
querying is very faster using Morales rather than
Exactly. Basically, the question you asked, like, how would it do the indexing wala part? So these APIs have taken care of the indexing part, and that's it actually for the indexing.
So they have done the indexing for us, which makes the querying faster. And
Cool.
I would like to add on the first question. I think what you're asking is if so, there's a metadata for every NFT, and what you're asking is, have we stored the encodings in the metadata itself, right?
Yes.
Yeah, we have stored them in the metadata, which is the payload, and we are
Okay.
comparing it from there only.
Okay. Got it. Understood.
Yeah.
Thanks.
If you want to see the metadata,
What all embeddings do you store?
basically.
So yeah, can you just show that?
Yes, Rudresh.
Okay, wait a second. I'll just.
You can go to the testnet and there you can get.
Go to polygon scan, the last one, last tab.
Last step.
For the embeddings, wait a second. Polygon scan.
Yeah.
I was actually going to show it on the cello, but we'll here only.
So just tell me theoretically, like what all do you store in the embeddings?
Yeah, that in the we store a particular 512 indexed array, which are the embeddings given by VGG19 model, deep learning model. So that for the particular image we got, this is the thing.
So basically, this is the metadata. So in the metadata, along with name, description, and image, we are actually storing the outputs given by the encoding layer of the VGG19, which are just 512 floats, and we're actually storing the floats in the metadata.
But do you know what this indicates?
Actually, there are some studies, exploring the latent space that these points indicate. But conclusively, it is not just some specific pixel and all those things. Actually, quantifies to the objects in the real world. So that is much more helpful for the regards of comparing similarity, not just the colors and all that.
Okay, and how do you do the comparison? Do you use the Cloud Vision API?
No. For the comparison, we're actually just calculating the cosine similarity. So that works very well because this is the traversable space of the encoding.
Okay.
Okay.
Yeah. Okay. Fair. I'm done.
Okay.
Yeah. Anyone else?
Raj sir, do you have any questions for the team?
Sir, you're muted.
I don't think Raj has
okay.
any questions. We can continue. Thanks.
Okay. Thank you very much, everyone.
Okay, so we have no questions anymore. Thank you, Team Allied. Now I request you all to leave the meet. Online participants, we will be back in a few minutes with our next team. Thank you so much.
Thank you very much, everyone.
Yeah.
Welcome team HalfByte. You will now be presenting the judges. You will be given strictly 10 minutes in that you have to present. I will be giving out a reminder of 5 minutes and 1 minute left for presentations, and then the judges will be asking you. You can continue.
Yeah. Hello, can you hear me?
Yes, yes, we can, Anyan. Ainan.
Yeah.
Please.
So our team is HalfByte, and these are our members. So our statement, because as we know, after the onset of the pandemic, communication has really been a struggle, and what we have depended on are the video chat applications. But the people with physical or intellectual disabilities are unable to use these video chat applications because they're not made for them or they for them. So what we want to develop a web-based video chat application for them, so that it can be assistive to them, because they cannot, they are unable to use those keyboards sometimes, or maybe talk, or other things. So they are able to connect emotionally with others across a distance. So the idea approach is we plan to build a video conferencing application that's free and accessible for all. We like to stress that we are most importantly we're focusing on the interfaces right now, more than the video chat applications. So we are bringing 4 modes, and through these 4 modes we are trying to target the 4 specially abled sectors. So our first mode is the Avaz, the voice-based control. It is for the people that are visually impaired. So the whole navigation of the website is through voice-based commands, and it also gives you feedback so that you know where you are. The second is the mode 2, that is the Sparsh. This is for the people that belong to the autistic spectrum. They have a problem in forming sentences and speaking. So they're given these core boards that you can see on the right to express themselves. So that is what we are providing as an interface to the people that belong to this spectrum. The third mode is for people that are severely physically disabled or are in locked-in syndrome, cannot use their hands. So what we proposed to do was a eye gaze based mechanism to track whatever they're saying. But due to the time constraints, we could not fit in the model and being able to work with our interface. So for right now, we have the interface. For mode 4, it is the sign language translation. So there's a live translation that is going on. It detects your hand movement and tells you whatever the user is trying to say. And again, due to time constraints, the model being heavy, we couldn't deploy it. And right now we have the limited vocabulary because we are dynamically providing the output of the text. These are the tools and technologies, and I would like to hand over to Rahul, who will show you the mode 1.
Okay, so I'll start with the mode 1 demonstration. The screen is visible?
Yes.
Yes, it is.
Okay, so I will be demonstrating the mode 1, which is voice-based control for those who cannot use mouse or keyboards. So we are using Alan AI as a voice assistant. So I'll start with the voice commands. Alan, click on create.
Clicked on create button.
Alan, create room.
Room created successfully. Select your mode.
So after each command, if the Alan recognizes the command, so we get a response. Alan, select mode 1.
Mode 1 selected successfully.
Alan, click on submit.
Clicked on create button.
Alan, click on create room.
Clicked on create button.
Alan, create room.
Room created successfully. Select your mode.
Alan, select mode 1.
Mode 1 selected successfully.
Alan, click on submit.
Entered into meeting successfully.
There was some issue with the voice recognition. Uh, Alan, turn off my video.
Video turned off.
Alan, turn off my audio.
Voice muted.
So now we are in the meeting. So if you want to invite your friends in the inside the meeting, so we have a friend list system. So you can send the mail to your friends by just saying the name of the friend, and the mail with the room ID and the meeting link will be shared to that person via the email. So I'll just Alan, share link with Rahul.
Returning to home.
I think Rahul, we can go to the next mode. Only 5 minutes are remaining. So let's take the next.
Alan, end meeting.
Meeting left.
Alan, return to home.
Returning to home.
So this was the demonstration of mode 1. So we have some issue with Alan voice assistant.
Hello everyone, this is a demonstration for mode. So as Anne explained about the vocabulary code base the instructor currently uses, so we have this web interface that video of the child will be here and the instructor video will be available here. Now here we have provided this tile based color coded scheme. So whenever the child will click upon the particular tile, it will be gone into text to speech and it will be sent to the user in this layout. After that, you can create sentences, and once all the sentences created, he or she can click on the speak icon, and then the sentence is then communicated to the instructor. So in this way, we have provided a mode 2. These are the various styles like adjectives, questions, emojis, alphabets, and numbers. Just click on any of the types, and then it is communicated. This was about mode 2. Now I will also be explaining about the mode 3. So as earlier explained, due to the heavy machine learning model, we are not able to deploy the mode 3, but we have created the front-end part. So here the video will be available. So here the basic idea was with the help of our eye tracking, we will select this particular tray and the word will be selected and that word will be appended to the sentences. So I will just show the implementation using front-end. So whenever I click on enter, this cursor will move, and if I click on space, that word is being appended into the word sentence. So in this way, I can append as many words as I can. So as you can see, good and I am are exported in this tray, and when I click on speak, it will be called. So this is the implementation of the mode 3.
Okay, so I'll be showing you the last mode, mode 4. I hope my screen is visible. So this is our last mode, that is sign language to text conversion. So you can see we have only vocabulary because obviously we didn't have the time to create the data and train it for everything. So till now we have met this.
Yeah, so we're done with our presentation.
Okay.
Yeah, we're done with
Okay. I'll stop share.
So how you taking in, so video chat और वो सब WebRTC से कर रहे हो, right? Are you using some API or are you building it yourself? WebRTC खुद से किया है connection?
So in the video chat application, we are using the KJS and the WebRTC.
Okay. And voice recognition के लिए Alan है. How are you doing the? How are you doing? So does Alan provide a platform where you create entity to intent mapping kind of?
Yes, sir. Yes. In Alan
So
Studio, we specify all the commands, and to that using socket programming, all the commands are sent to the application, and then the action for that command is specified on the JS file on the client
Got
side.
it. Okay. And for the sign language, what model have you used?
So what we did was we had taken the media pipe, which already gives you the hand key points, and on these hand key points we collected the XYZ coordinates, and through this we trained them through sequences, and from the sequences we got our final model.
Got it. Cool. Thanks so much, team. No questions for me.
How much of training was required? Like,
So currently, because our vocabulary is limited, so it's limited to 12 words because we couldn't collect, a lot of data in the required time. The time taken was very less. It was not a huge amount of time, but considering all the dependencies that we had with our model, the libraries, it was tougher to deploy. That's what.
We have one question from Raj sir. Given time, if you want to integrate it with a platform like Zoom, how will you do it? Like, how can one use a platform? Sorry, how can someone use your platform to join Zoom or Gmail?
So what we have is right now we have the interfaces that we are saying. So our interface is one of the main parts because the video calling is available everywhere. So as you can see, we have the 4 different modes, and each of these modes can be selected. So if, for example, if a person cannot see, he can use our mode 1, in which we can do the voice-based navigation. So all of these interfaces that we have, we can put on, if you want, you can put it on Zoom, and through Zoom you can utilize this however you want it.
Also
also
for
adding to
mode
the
1, we can develop a Chrome extension for specifically for mode 1 and for voice-based recognition.
Thanks. I think no further questions from us.
Thank you so much.
Thank you so much, team. Now we will have a discussion of the quiz. You guys can leave the meet right now, and online participants we will be right back with you, the next team.
Good
Hello and
evening.
welcome team through Rubik's Code. We welcome you all. We will be presenting right now in front of the judges. You will be given strictly 10 minutes in which you have to present your entire project. I will be giving a reminder of 5 minutes and 1 minute left. After that, we will have a round of the judges asking you questions about the project. Thank you and all the best.
Yeah, I'll just start presenting. 1 minute, please. I'm not able to screen share. Hello. We are facing some issues. Give us a minute, please. Good evening. We are Team Rubik's Code. Today we will be presenting our Chrome extension, Save Social. Our Chrome extension is built to reduce the amount of negativity spread through social media platforms like YouTube and Twitter. Uh, Our today's problem statement takes inspiration from a common issue among YouTubers and other people prominent on social media, the negative comments. The negative comments hurt more than people realize. We decided that this overlooked issue deserved to be brought to attention and that we could develop a solution not only for the individuals but the rest of us as well who often come across such disturbing comments while casually browsing through these social media. So, what is Safe Social? It is a Chrome extension which is used to block hateful and offensive comments on social media sites like Twitter and YouTube. It analyzes the comment section for any hateful messages or content and renders it unreadable to the user by censoring or blurring it. It constantly checks the page for hateful comments. If user loads more comments, our extension will pull those up. Please note, Safe Social is not meant to censor constructive criticism. Rather, it combats comments which are purely malicious in intent. Main reason for the need for Safe Social is as follows. First, it will help users to avoid negative and hateful comments, ultimately protecting them from cyber hate. Secondly, it is made in Manifest version 3. Unlike most Manifest version 2 Chrome extensions, it can also be used after June 2023. Thirdly, as per the current provisions on Twitter and YouTube, unless a comment has been reported a number of times, it will not be hidden or blocked. The features of Safe Social are as follows. It targets Twitter as well as YouTube. It is extremely user friendly and can be easily downloaded. It helps in fighting cyberbullying. It minimizes online harassment, and it has enormous amount of target audience. One of the main features is that it is made entirely in Manifest version 3. After June 2023, it can easily be used as Manifest version 2 Chrome extensions will be deprecated. This is our architecture diagram. So first the user uses YouTube and Twitter with our safe extension installed. From the extension we get tweets and comments which are sent to our fast API, from where it goes to in our machine learning model which has 4 primary stages: text pre-processing, followed by tokenization, LSTM model, and finally the prediction is made, which is again sent to our fast API. If it is hateful or offensive, the comment is censored, and so the user is shown the following via Chrome extension. Now we will be giving our demonstration.
Yes, so now I'll be running the code. So now, as the extension hasn't been deployed yet, so I just run it in the developers version. Yeah. So let's start from YouTube. So these are the YouTube comments of a song Thrill Shot. As I scroll downwards, the comments will get. As I scroll down, the comments will get processed, and then I will get a result at some point that the comments are which are blocked will be displayed. I guess I'm unable to figure out why is there the comments are not getting blocked. But as you can see over here, we have segregated the comments in unblocked and blocked comments version. So, for example, if a comment is blocked, it just showed that it's unblocked comment, and if the comment is blocked, it is shown that it's a blocked comment. As of now, there are not really any blocked comments which are to see in this external version. Yeah. So there's another feature as well that if I type a comment which is abusive, for example, yeah, so it gives me a direct indication that a setup is hate and abusive by the ML model. If I change the comment, yeah, so the comment now says that life is happening as a no hate comment. We face issues with synchronizing this comment section to the YouTube because initially at the beginning we had some undefined values, which basically over here, as you can see, we had some undefined values and there was a time constraint, so we were not really able to
synchronize the comments into the result on the front end. On the back end, we had all the clear results. For example, if I show you the backend terminal, it has all the clear results, which displays which comment is no hit and which comment is hit. But in the front end, we were not able to synchronize it because I guess we needed a database or something to connect it, and without 24 hours, we were unable to do it. Now moving on to Twitter. So this is the Twitter page. If I just scroll down a bit, after a point I will get to know that there are no hateful comments currently on this page, and there is no such comment which I can find which is hateful. Similarly, in this as well, if I have to type a comment which is abusive in some sense, for example, now it starts telling me that this comment I guess there is some issue. I'm not really sure. Let me just change the. I think there is some issue with the comment result. I'm not really sure. I think there's a problem with the ML model. I am not sure. But yes, so this was our complete implementation of the comment feature. We can now open the SafeLink GitHub, Safe Social GitHub, and we can explain the ML model and how does that work.
So I'll be explaining the ML model designed for this extension. So we have handpicked 5 datasets, namely abusive language, Twitter hate comments, sexist tweets, toxic tweets, and racist tweets. For text pre-processing, we have implemented the natural language toolkit along with regex and string libraries. The module's snowball stemmer has been used for selecting words from the English language. Tokenizer library. So we have combined all the 5 datasets together. The tokenizer library has been put into practice for converting text into sequential numeric data. This is in the form of a 2D NumPy array, which is then converted into a 2D matrix. This is where we have trained our model. And as you can see, the model accuracy is 93.8%. This is the confusion matrix, where we can see that out of 22.5k data points in the test data, 21.5k data points are predicted accurately.
So the tech stack which we have used for this project is HTML, CSS, and JavaScript for our front end, Python, TensorFlow, and Keras model for the training the machine learning model, and we have used Fast API in our backend. Some challenges which we faced was the making the model in 24 hours. It was extremely challenging, and it was difficult in censoring the comments and integrating our extension and Fast API. The value proposition is that any social media user or parents or guardians can use our Chrome extension, and because it is made in Manifest version 3, it can be easily used in the future. And so future prospects of our extension is that we can improve our censoring algorithm. We will include regional language-based abusive and offensive content, and we will expand our scope to other social media applications like Instagram, and we will also work on blurring graphic content like emojis and images. Thank you.
Judges,
So, yeah, just one quick question. Okay, I think there are two questions here.
Yeah, hi. So there is a question from Raj sir over here. What's the accuracy of the model? And the second question is, what's the goal here? What exactly your user will experience?
Yeah. So accuracy of our model is 93%. And to answer the second question, our main goal is to stop online harassment, which is mostly experienced by social media users of YouTube and Twitter. So what exactly our user will experience is that if someone downloads our extension, they will not see any comments which have any kind of offensive or hate content in. So if any comment, let's say, has some abusive language, our user will not be able to see it because our extension will blur and censor it. And along with that, if let's say our user is typing something which is not of abusive content, he will also be given alerts about it because he's like typing something which is not supposed to be on social media. So our user will be protected from the cyber hate, as well as try to inculcate that feeling that the user is not responsible for spreading any kind of hate.
Hey, so can you describe the model a little bit? Like, what does it do beyond word matching?
Yes, sir. Riddhiman will answer that question.
Okay, so basically our model, like in the starting, after combining all the five datasets, we basically first clean all the text, clean the text, basically every data point, so that we just take English words for training the dataset, like removing if there is any punctuation mark or any any like link given in the text data. So after that, basically it goes. Basically, we convert the every data point into. We basically tokenize the text data, and then we basically convert it into a sequence matrix, so that we can pass it in the LSTM model. Then we train the data set, and then after that, we used it for predictions.
And our data set is made up of 5 datasets primarily, which are like racist, sexist tweets, and like angry and so on. And other than that, right now we are trying to improve the accuracy of our model by correcting some false positive and even training it for some sarcastic comments. Because while testing, we realized that it is not able to like differentiate between sarcastic comments. We are trying to add that feature to our model.
So you said NSVM model.
LSTM model.
LSVM model. Okay. Yeah, okay, I'm good.
And judges, do you have any more questions or is that it?
I think that's it.
Perfect.
Thank you.
Questions from Raj sir as well. So, perfect. Thank you, Team Rubik's Code. Now I just want to leave the meet. Online participants will be back with the next team in a few minutes. Please stay tuned. Thank you so much. Hello and welcome Team OF1. Now it's your chance to present in front of the judges. You will be given strictly 10 minutes to present your project in front of the judges. I'll be giving a reminder of 5 minutes and 1 minute left. After that, the judges will be asking you questions based on your project. All the best and good luck. Thank you.
Good evening, everyone. This is Team Owen, and our project is Diagnow, that is diagnosis on the foot. So it does tracking, analysis, and reminder for the diagnosis. So what is the need of the project? So we have seen that many a times patients are reluctant to go to doctors and re-go through all the checkups to know what are their report results. And there are also being events where people use forged medical prescriptions where to access the illegal drugs. And also there are a lot of unhealthy people. Most of the people are unhealthy. So to try to solve these issues, diagnose come into picture. Diagnose come into picture. So what is the solution? So we are building an app that is one-stop solution to all of the before mentioned problem. It does analysis of medical report. It generates e-receipt, that is electronic prescription for users, diet recommendation, and also smart voice assistant is being integrated. So this is the basic UI of our app.
So now showing the flow diagram of our application. So when a user comes, he has three options through which he can use our application. First is to generate report. He has to submit X-ray or any kind of image that has some report, and we would generate report for him. The second is the data recommendation, where once you tell your calories per day, how much you consume, which diet, like vegetarian diet or non-vegetarian diet, we recommend the type of foods along with the recipes. And the third is e-receipt generation, that is to prevent forgery of medication. Like for example, when we go to medical without prescription, people forge prescription and take medicine. So to prevent that, we have introduced e-receipt. So initially, once we go to analyze report, we ask the user to submit the report, the image report, and then it would go to the backend where our machine learning model, which is trained using PyTorch, sees the report and gives output what the report says. For now, we have concentrated on chest and ECG. So it gives reading about that particular chest X-ray or ECG, and then we show it to the user in the next. The second part, that is the e-receipt. In the e-receipt, we have created two UIs, for one for the doctor, one for the medical store. The doctor takes the patient name, age, and he generates a prescription like the medicine dosage and how many days you want to continue, and then four phrase words is generated, which is given to the patient. The patient takes this phrase and goes to the medical store. Once the phrase is given to the medical store, the prescription is shown on his UI. The last one is the diet. In the diet section, we take the calories and the diet preference, and then the diet is shown to the user. Next.
So tech stack used in building Diagnow are as follows. First of all, ML model was built using PyTorch, and API was done using Fast API. Application was built using Flutter and Provider. Web application was built using React, Node, and MongoDB as a database. Hosting of app was done using Heroku. Web was done using Netlify, and ML model was done using Docker. Figma was used for designing. For voice assistant, we have used LNAI. And for data, we have collected data from these two sources. So future scope of project can be, first of all, we're thinking of including training more models for different health issues. We can also recommend nearby doctor of respective health issues. We can also add medication reminder for the patients. We are also thinking of adding patient medical resources on the cloud, so other doctors can also easily access the authentic reports. Business model can be as follows. First of all, we are thinking of including premium membership for more disease detection, and we are thinking of taking some charges commission from the free patient books and appointment from the Diagnow. Now Prajwal will show the implementation of Diagnow.
Yes, I'll be sharing my screen right now. 1 second. So I hope my screen is visible. So we have actually created a mobile application that the user will be used to access our application. So this is diagram. So as you can see, this is the dashboard of our application. So we can first of all we can see the accuracy of our model that we have trained, machine learning model. So for the report analysis, the first part is report analysis. Then we have e-receipt section. Then finally we have a diet plan section. So first of all, let's see the diet plan. So as you can see, as soon as we go here, we can see target calories, our preferences, etc. So we can select the target calories that we want to eat. Suppose 500 calories. We can enter our preference, veg or non-veg, and as soon as we click on this check diet, we can get a recommended diet plan. And you can see the calories that are mentioned here. We had targeted for 500, and all the other nutrients that are along with this diet plan. If we click on a particular food item, we can access the recipe for that food item. So as you can see, this is the food item. Then moving on to the next feature, that is the e-prescription. So for this part, doctor will be entering the prescription from his end. So for example, the doctor will log in here, and the doctor will be shown this screen, so he can enter the patient details, age, and the recipe and the medicines that he wants to recommend, along with the dose, this strength, 250 mg, the number of days. I can just enter more. Yes, so if we click on create, this will create a unique secret phrase that we have mostly seen in technologies like MetaMask. So just we try to replicate that idea and create a secret phrase for every user. Now, when this secret phrase is entered for that user in that application, let me try to enter it. Let's click on prescribe medicine, and as soon as as it is, the data that has been prescribed by the doctor is visible on this application. So this was the another feature, and this another feature, that is the analysis of report. So for now we have chest and ECG reports. So when we enter chest report, we can enter an X-ray. So for example, this is one of it, and get the report. So we can see for this X-ray that the disease predicted was effusion and some other details. Similarly, for ECG, we can enter another image, another ECG report. For example, this, we can generate the report. And as for this ECG report, the disease was there wasn't any disease, so it has predicted to be normal. And along with it, there are some other details mentioned. The final feature, that is the voice assistant. So we have tried to integrate the Alan voice assistant in this application to get general healthcare details. So let me try this. Hello, healthcare.
This is your healthcare voice assistant.
So I hope that was audible. Let me try another commands. I am unable to sleep.
How long have you been unable to sleep?
2 weeks.
It looks like insomnia caused by lethargy. You have been under stress for quite some time now. Try to relax a bit by experiencing fresh air.
I can also try some other commands like what should I contain in a balanced diet?
Starchy food such as bread, rice, potatoes, etc. Fruits and vegetables, milk and dairy products. Protein foods like meat, fish, eggs and other non-dairy sources of protein including nuts, tofu, beans, pulses, etc.
What are some of the symptoms of lung cancer?
A cough that won't go away, being short of breath, coughing up blood, an ache in the chest or shoulder, loss of appetite, losing weight. Chest infections are all the symptoms shown by someone who might have lung cancer.
So yeah, that was it for our application diagram. So I hope the voice assistant was audible to all. That's it from our side. We can answer some questions now.
What was the tech stack again?
Yeah, the tech stack was Flutter for the mobile application that I just showed you, and for the doctor's side, that is creating and creating prescriptions and giving all the medicines. That was a web-based application. So we use React.js, and all the APIs. The backend server was created on Node.js, and the database used was MongoDB as mentioned here. And finally, we were able to deploy our application. So the web application was deployed on Netlify, backend on Heroku, and ML models were also deployed on Heroku using Docker and these technologies. Yeah.
And you're a team of two that did this?
We are a team of
four.
Okay.
Judges, any questions?
Did you have to train any models?
Yeah, so for chest and ECG part of the report analysis, we had to train a ResNet 50 model for giving the output. That is a convolutional neural network model.
And who came up with the output content? So one of your examples, fluid is.
Yeah, so for in our data set, we have 14 diseases for chest, and currently one disease for ECG, and for each one of them we have manually found out the what are the reportings that we need to do. So as and when an ML model gets the prediction of a particular disease, it checks in our database and returns that following value, all the report that we have generated.
Where did you get the X-rays from? Is it available online?
Yeah, National Institute of Health, and ECG was one more institute that was being mentioned. Yeah, so data, National Institute of Health, and Parvez Ilahi Institute of Cardiology. So we have got the data from there.
Okay. Okay, Raj has a question. Can each of you explain the part that you worked upon exactly?
Yeah.
Yeah.
So Abhishek, I was responsible for creating the entire Android application using Flutter. So I created the UI and integrated the API, that API, the API with the machine learning model, and the API with the medical e-receipt.
And for machine learning, Jaideep Jethwa was one experienced in
Yeah.
machine learning project. So he worked on training the models and giving the particular output.
Yeah.
I and Ravi, we both worked on creating the web application for the doctor, and we also created the server backend. So all the APIs, so all the APIs were created on Node.js. So this was our distribution of work.
And also the LNAI training part was done by
Yeah.
Prajwal.
Yeah.
So for describing the ML part in depth, as we saw the two data sources, we trained our model. That is, we downloaded the pre-trained model from Torch Hub, which is already trained on a data set, and fine-tuned that model for our particular use case, that is chest and ECG. And after that, I developed a API to serve that model, that to make it available for the application that we have developed. And as the file size was very large for the API and the models are in huge size, so we used Docker container to deploy it. So we created a Docker image and uploaded it to the Heroku platform. And Ravi also used Figma for
Designing all the
application.
Is there any more questions or is this it?
So while you were developing this, did you face any bugs which
Yeah,
Yeah, yeah.
actually,
So the main issue was in the machine learning training part. Initially, when we started working with the machine learning chest X-ray part, the data set that we got was quite huge. So once Jaydeep trained the model, there was there was issue on the column names, and while creating the APIs it was not correct. So we had to retrain that model. Jaydeep, can you explain what was the
yeah,
details?
so while developing, the outputs were very small in number, so it wasn't so if a disease need to be predicted, it should cross a particular threshold. But while training, it was perfectly fine. But when we served in deployment, the predictions were not crossing that particular threshold. So I had to retrain the whole test module and again develop the model and develop and test it again and
And
do the
another main issue that we faced was the integration part, where different parts were on localhost. So while deploying it on particular servers like ML model on Docker, so we were very new to Docker. So there was a lot of errors coming while deploying it. So that was also a major issue that we faced.
yeah.
What were the kind of errors that you got on Docker?
Yeah, so Docker, well, we need to have a requirements.txt file for Docker, right? So some of the compatibility issues were there for we even though we had created a virtual environment for using the project, some of them were not compatible in the Docker container. So we had to fix them according to particular document. Also, while deploying it to Heroku, there were issues like sometimes when the application won't load. So we need to specify perfect command prompt command that we need to give to the Heroku in Docker file so that it perfectly fits with the Heroku system and the Docker image.
Okay. Okay. I'm good.
Thank you.
If there are no more questions, thank you, team OF1, for joining. Now you can leave the meet. Online participants will be back. Will be back with the next team soon. Thank you so much.
Thank you for
Yeah, yes, we are ready.
Okay, hi and welcome Team Skill Amateurs. You'll be presenting now in front of the judges. You'll be given strictly 10 minutes to present. I'll be giving a reminder of 5 minutes and 1 minute left. After that, we'll have a round with where the judges ask you questions about your projects. So go on and all the best.
Yeah. So our project name is Marksheet Cello Blockchain Ledger, and we are skilled amateurs. Uh, my team is me, Achal Jain, and Sakshi Pandey. In this PPT, we are going to cover 6 points: problem statement, motivation, proposed solution, tech stack use, execution strategy, and future plan. So our problem statement is basically, see, I think you guys have seen a web series called as Suits. There's a guy called as Mike Ross who is practicing law. He fights cases and he doesn't even have a law degree, and he gets away with it easily. So that's our problem. And we all have gone through the pain of filling tedious application forms, maybe for a job or maybe for an abroad college. But we all know how tedious it is. That brings us to our problem statement. It takes a lot of efforts to get all the certified mark sheets in one place when you apply for any university. You have to ask your college multiple times for transcripts. You have to go to that certification sites for getting your certificates in order, and that's a tedious job. And marksheet is just a piece of paper, so anyone who is creative enough can make a good copy of it, tamper it, forge it, and then there is a whole lot of things that happens. And if you lose a mark sheet, then you have to do a FIR report. You have to visit your university multiple times and even pay thousands of rupees to just get a copy of your original mark sheet. This is the problem that needs a solution. So there is a need for a globally trustworthy digital vault for storing all the certified mark sheet, so that application process becomes simple. It should be universities must upload their students' mark sheet on blockchain where they will be stored in a vault. With the world going digital, it is critical that verified mark sheet should be stored digitally so that they can be treated in the same way as any official document is treated. So, what is our proposed solution? Our proposed solution is that we store marksheet over a Celos blockchain in such a way that a university can fetch all the academic details of a student just by entering his universal roll number. Marksheet can be entered into ledger, can be added into ledger by only the organization knows. That means only university can add a marksheet. So forging or tampering it becomes like impossible or out of equation. Now, as you have as you have mark sheet over a blockchain, even if you want to forget your marks, you can't, because it's going to stay over there for eternity. So there is no way that you are ever going to lose any mark sheet or even temper it. So what exactly we use? We use Solidity for building our smart contract. We use Cello for deploying our Cello as a blockchain in which our smart contract is deployed. React for our responsive front end, and Node.js for our efficient backend. So now I'll show you a system demo in very short. So see, this is basically our dashboard that you are shown. So let's say a particular student named Achal Jain belongs to KJ Somaya College of Engineering. So your KJ Somaya College of Engineering logs into this portal and it clicks on adding this student. Okay. So let's fast forward where they click on add student button. So now when add student button is clicked, they are shown this beautiful UI where they enter the name as Achal Jain and they enter her roll number as 1811032. For now, we have used our college roll number, but this will be a universal roll number. Okay, so every student across the globe will have this universal student ID. So let's assume it's 1811032, and when add student button is clicked, student is added and the transaction happens in blockchain. Now we go to the second part. Second part is when KJ Somaya College of Engineering now wants to add mark sheet for this student. So it clicks on add mark sheet. It enters the student ID, which is 1811032. It enters the mark sheet title as SSC document, and it enters the number of subject as 2. Once this is done, they add the mark sheet. You are shown a pop-up where mark sheet ID is 1 for student ID 1811032. Mark sheet, to remember mark sheet ID is key here. So we remember mark sheet ID as 1. Now it's time for entering the marks. So marksheet ID is written. I'll fast forward this. We'll enter 2 marks. So marksheet ID 1 is entered. Subject number is 2. Subject name is English. Marks obtained 90 out of 100 and status is pass. And marks are added. Now it's time where Achal logs into the system and Achal is shown this beautiful UI with just a view marksheet option. Okay. We didn't have enough time to customize it. So we have shown all the 3 dashboards. But when Achal will log in as a student, she will only be shown view marksheet option. So when view marksheet is clicked, Achal can see her own mark sheet as 1811032 and she can see her marks. But let's say that now Achal has applied to CMU college in USA and Achal doesn't want to doesn't want to fill all the mark sheet. So what she will do is she will share her 1811032, her unique roll number in the application form. CMU will log into the system and CMU will enter her roll number here. So when CMU enters her roll number, CMU will see all the list of mark sheets that Achal has. Currently, she has only one mark sheet here, so SSC is shown and her status is also shown, pass and fail. It can further click on this mark sheet and then see the subjects here. Okay, so all the subjects history will be shown. So just by a click of button, CMU was able to fetch all the mark sheet details of a particular student, and Achal was able to store her mark sheet over a blockchain ledger, which she can share with any organization in future. So this is our project in brief. Now let's come to the big part. Um like, why will someone use our system? Okay, this is the most important question. So basically, every college like spends around 7,000 rupees to just review a single application of a student. Most of this money goes into storing the uploaded documents, doing compliance check, verifying it with the other organizations, having their manpower invested in doing all these things, and getting it verified from the source. Now, our system gives a viable and better alternative to this process. So colleges can divert the money in giving us infrastructure for that blockchain. So here's how we get our infrastructure for the blockchain. Now, as the system progresses, as more and more colleges use it, students will demand this feature as it would ease in their life because they no longer have to fill all these tedious forms. They just have to share this unique ID and all their academic history will be fetched. And the network itself will give colleges a sense of being reputed. Like if all the IITs and NITs are there, then obviously Somaya will get much more reputation by just being in that network. So that's how more and more colleges will start taking our blockchain as the alternative for distributing mark sheet to their students. And future scope. So future scope is that we know that the UI we implemented is not user friendly, but still in future we can integrate this system with the LMS, learning management system of colleges. So colleges does not have to fill this form manually. We can have OCR as well, where they can simply scan the mark sheet and all the details will be fetched into the system. And we can also have an mark sheet storage facility where actual mark sheet in some format is stored over the blockchain, not just its data but the actual mark sheet itself. So that's a brief presentation. Any questions for us?
Yeah, how much, like, so on the back end, what sort of integrations you've done? You said Cello and
So basically, we had a contract deployed on Cello, and we used backend to like interact with that contract using Web3. So we interacted with that contract. We then integrated with the React frontend also. Like frontend and backend were two different modules for us. So we built APIs in Node.js, which would give data to React to display. And the backend also had the connection with the smart contract where it used to fetch the data for us.
and can anyone fetch anyone else's data, or can you build some restrictions over there?
Yeah, we can build those restrictions in the backend, like in the smart contract logic itself. Like there can be RBAC, like user-based access, but for now, for now, the system does not have that. Anyone can fetch anyone's data. In future, we can have this kind of implementation where someone can request and student can approve whether that organization can fetch his or her data or not.
Okay.
So, there's, I mean, I'm trying to understand what's the differentiator or unique feature you have, because I mean, so many people have been doing this. I'm a bit unclear on where kind of you have a right to win or
See,
something at K which really attracts me.
we are not just creating a hello world project in blockchain. Okay, we are doing this with a brief understanding of the problem, and we are here with the execution strategy as well. Like when blockchain comes into picture, infrastructure becomes impossible to implement, right, in the real world case. But we have a valid idea, valid structure where not only blockchain is used to store mark sheets, but it will be used to do all the future applications. When you apply for a job, you don't have to fill that complete form. You just have to give your unique id, and all your academic details will be fetched. So this is something which is not there. The execution strategy is missing in all those projects, and even the idea and the simplicity which we have in this project is itself a beauty. Like even after being such a blockchain based project, the ui is pretty simple, the understanding is pretty simple, and for user it's as simple as just giving your id and someone can fetch your details. So that's,
Can we see the contract that you written?
yeah, sure. Just a second. Achal, can you show it on your screen?
Yeah, just a
Hello?
second. Yeah, just a
Yeah.
second.
Okay, I'm ready with the contract also. I'll share my screen again.
Yeah, okay.
Yeah, this is the contract.
Okay.
Any more questions?
Is this live on a testnet?
Uh, yeah, you can. The contract is deployed on the Cello testnet. Yeah, it is live. We forgot to attach the screenshot for it, but yeah, it is live. I have the address and ABI for it.
Yes.
Okay, can I see?
Sure.
Can you
Just a
share the
second.
details?
Yeah. I'll share it with you again. Just give me a second. Yeah. Here you have the Web3 provider, which is listed here, and then the private key stored in the environment environment file.env. This is the private key, and there is also a file called as connection.js. If we removed it, see, I'll show you this. So this is the address and ABI for that contract that we have deployed. So you can see all the features that were shown here, like add marksheet and so on. So these are the metadata for that contract.
Okay.
Yeah.
So I guess there are no more questions. So
Yes.
I'll thank the team amateur, skilled amateur, and now you guys can leave the team. We will have the session for judging, and online participants will be back with our next team right away. Thank you so much.
Thank you.
Hello and welcome Team Kratos. We'll be presenting now in front of the judges. You'll be given strictly 10 minutes to go through your presentation, and I'll be putting up the reminders for 5 minutes left and 1 minute left. So go on and all the best.
Okay, thank you. So, hello, is my screen visible? So yeah, so our project name is Timsai. It's a video player. So our team members are Mihir Panchal, Syed Qureshi, Lekha Khobrekar, and Yash Darshi. And our team name is Team Kratos. So onto the table of contents, overview, problem statement, requirement analysis, tools and technologies. Also, we will be covering features, solutions, prototype, future scope, and conclusion. So onto the overview. An open source cross-platform Python GUI application. We are developing a Python GUI application. So in that Python GUI application, we are getting user input through mic and through text, and we are processing that query, and we are onto opening a YouTube video. So it has multiple features in it onto the problem statement. So the problem with YouTube is that not optimal search query is being generated each time when we search on YouTube. So also there is not more user friendliness. So not all walks of life can control and work on YouTube. So our project aims to make some useful project to people who are blind, who are disabled, who are autistic, and who are limbless or are disabled. So onto the requirement analysis. So we are using machine learning, speech recognition, and gesture recognition to give user friendliness. And the project is completely open source. So our source code is shared on GitHub, as well as if you give me the mail, I can mail it to you as well. So onto the tools and technologies. So we have used just Python and its libraries for this project. So first is the Python 3. We use Python 3, and all the versions above Python 3 are compatible with our software. Next is TensorFlow and OpenCV. It is used to recognize the gestures and for manipulating the video like forward, reverse, pause, play, volume up, volume down. Also, we use speech recognition to search the video, what you are looking for. We use PyWatKit, a library, to access YouTube through our GUI application. Also, we use tkinter to make the GUI of our application. Onto the features. The first feature is speech to text. We are converting our speech into text format, and that text format is being searched by YouTube, and a YouTube video is open. So next we have text to speech. Our GUI application also gives voice commands in speakers. Also we have TensorFlow and OpenCV to navigate to the video through gestures and inbuilt camera, and it's totally portable desktop GUI application. So you have to just download the zip file and run the requirements.txt, and your project will be running okay if you have Python 3 and above. So there is inbuilt automation and controlling of the application. So next on to the solution. Solution is that we give user friendliness to the end users. End user may be able or disabled, no matter what, he will get a proper solution to it. ML based solution for better accuracy. Our model makes it accurate for users to search the video we want to, and user has to directly search for the keywords in our GUI application, and there is a large scope of it in content creation in the future. So onto the prototype. This is our Python GUI application. Onto Sarit to show the actual prototype. So Sarit, please present.
Yes.
So yeah, Sarit's video is on. Sarit has run the application. This is the GUI application. Sarit, just type some Java tutorial and press the search button. Automatically a YouTube video is opened. So this is the first way to search a YouTube video. Sarit, please close this window. Okay, onto the GUI again. Now go for the voice command.
Vocalize tutorial.
Python tutorial.
So Sarit just spoke Python tutorial. And I think you misspelled it. Go on to the command prompt. Command prompt. Yeah, you said London Fog, so that's why it's showed that. Do it again.
Vocalize tutorial.
Python tutorial.
Sorry, couldn't hear you.
Do it again, Sai, please.
Vocalize tutorial.
Python tutorial.
Sorry, couldn't hear you.
I think there's a technical glitch. Shall I present? So yeah, I'm sharing. So this is the Python Geo application. So onto the voice command.
Vocalize tutorial.
Java tutorial. So yeah.
Hi, my name is Mosh, and I'm going to be your instructor in this Python course. In this course, you're going to learn everything you need
So
to get
it
started
took
programming in
tutorial,
Python.
and according
Python
to
is one of
that,
the most popular
it
programming
opened the
languages, and
Python
every day people
tutorial.
use it.
Let's do that again. Can we have judges to search a query?
Yeah, can you search for IPL cricket scores?
And Sarit, again, share the screen.
Vocalize tutorial.
IPL cricket scores.
Sorry, couldn't hear.
I guess there is some error.
Sell online and grow your business with Wix e-commerce. Create a beautiful store. Complete by
Okay, Sarit, let's just go on to the gesture recognition part. Click
programming
on the
starting
gesture
today। मैं आपसे
recognition
कहूंगा,
button.
इस वीडियो के साथ मैंने अपने हैंड रिटन नोट्स इंक्लूड कर रखे हैं ताकि आप लोग वीडियो के बाद अच्छे से रिवीजन कर पाए। इस वीडियो को मैंने 13
So yeah, gesture part is opened. So yeah, Sarit, can you full screen with a rock sign? So yeah, in the meet team, he just did a rock sign and the full screen happened. Again, minimize the screen. Now again do it, rock sign. Now volume up using thumbs up. Okay, okay. Play the video by OK sign.
दो प्रोजेक्ट्स गेम होने वाले हैं और एक प्रोजेक्ट हमारा
Okay.
LMS हो चुकी है
Now
सिस्टमों का। अपने
volume down.
ट्रिक्स शेयर करूंगा आप लोगों के साथ। लॉजिक बिल्डिंग में जिन लोगों को दिक्कत आती है इस वीडियो के बाद वो सब इतिहास रह जाएगा। अच्छे
Pause
प्रोग्राम आप लोग लिख
with
पाओगे।
OK
यही
sign. Now rewind the video with a peace sign. Okay. Now forward the video with a rock sign.
Yeah, I think team, let's pause here. This is good enough. Your time's up and we've seen enough. So basically, this is a layer on top of regular search, is it?
Sort of.
And you've just added a layer of audio recognition and sign language recognition.
Yes, yes.
Okay. Were the sign language models built by you, and are they based on any actual sign language or just signs that you believe you wanted to train for?
No, these signs were given by me.
Okay.
When creating the model.
Okay. Cool. ठीक है, no questions from my end. Thanks, Mihir.
Okay.
Raj, Harshal, any questions?
Not really. I think I'm good for this one.
Cool. I think thanks so much, team. Thanks so much for your presentation.
Okay, so I see there are no more questions. So thank you so much, Team Kratos. You can now leave the meet. We'll have a discussion session right now. So online participants, we'll get back to you with our next team right away. Thank you so much.
Thank you.
Hello and welcome to MangoDB. You will be given 10 minutes to present your project in front of the judges. Oh, I'm sorry, you'll be given 8 minutes to present in front of your judges. And I'll be giving you a reminder of 4 minutes and 1 minute left. So go ahead. And then we'll have a session of where the judges will ask you questions about your project. So go ahead and all the best.
Yeah, actually, there was a problem from my PC, so I'll be speaking from here, if that's okay. Yeah, I'll be presenting my screen now. Yeah, so we've named our project We Learn, and team name is MangoDB, and it's me, Jainam, Avish, and Jai. So, what was our problem statement and why we chose that? So, plain theory can be really boring and monotonous sometimes, eventually leading us to lose focus on the stuff that we're actually supposed to be concentrating on. Aiding the loss of concentration was this COVID era, leaving us students with a lack of attentiveness and sense of responsibility. So what our solution aims at providing and the user flow of our site. So how are we aiming at solving the problem? First step would be gaining knowledge. Learn about different things with the help of our courses that we provide it on our site. Next is gamifying and visualizing. With our site, we help students learn faster by visualizing the concepts and gamifying them. I'll be showing all of this to you on the site. Tests and quizzes. Users can take tests and quizzes made on our sites and also get to know about and participate in all the contests being held across various competitive platforms as well. So you can take quizzes that we are providing on our site, as well as you can get to know about all the coding competitions being held across various platforms. Track themselves. Track their own progress with the help of our site. Take mock interviews. Users get the advantage to take mock interviews in order to assess their advancement and get themselves rewarded as well. Subscription plans. Based on the plan they buy with Ethereum through their MetaMask wallet, they can avail different advantages. Our target audience. First is the students. All the students who have these subjects or concepts in their curriculum and want a better understanding of it can use our website. Next is any knowledge gainer. Our site is not just restricted to students. Anyone with a will to learn can hop onto our site as there are no prerequisites because we start from the very beginning and take regular evaluations as well. Future scope. Rewarding NFTs. So this is our future scope that we wish to implement but couldn't because of the time constraints. So the students would be awarded based on their performances in the various tests that they take. Library. The students need not go to other sites for books. They can get access to various resources through our site itself. So what we're planning to do is get themselves a page where they can look for any book that they need so that they need not venture out to other sites apart from ours. Study group leaderboard. Students can collaborate and study, which gives them the sense of a healthy competition. One-on-one contests and its analysis. Users will be able to compete with each other live while the competition is being held and can analyze and evaluate themselves and also get personalized recommendations based on their performances. So all this that we are doing is to maintain the user flow and to restrict the users to our site so that we get a higher percentage of repeated users. So this is our AAA business model. First is assist. Assist our users in helping them learn new topics and concepts. Assess. Assess our users by tracking their activities, tests, and progress. Appreciate. Appreciating our users' efforts by rewarding them points in the form of NFTs. So it's AAA, assist, assess, and appreciate. Now we'll move on to our site. Yeah, so this was the help board that we've created. Like ask me something. For example, I put help. What can I help you with? If I ask for contests, so you can go to our contest page for all the contests being held, and then I can go here. Yeah, thank you.
We're up for questions now.
So why did you use NFTs over here? Hello?
We have used MetaMask for the students to buy a subscription. NFT was in our future scope. Like we wanted to reward the students with NFTs. Like for example, if they take a particular quiz and if our the contest that would be held on our site for like the top 3 students or something, they would be rewarded NFTs from our site. This is what our future scope sees.
But how will the value of the NFTs appreciate?
It would be just for the NFT collectors now. Like it's just a matter of attracting users.
Okay. Okay, and what did you use to analyze the mood of the interview?
We have used Symbol AI.
Okay.
Yeah. It,
Okay, all right.
Yeah, I think just wanted to understand. So this whole thing was built in the 24 hours,
yep.
and this is a team of how much?
Team of 4.
Okay. Cool. Looks good. I think no further questions.
All right. Thank you.
Thank you.
Guys, if the questions are over, then we'll move on. Thank you so much, team, for presenting. And now you can leave the team. Sorry, now you can leave the meet. And now we'll have a discussion session with the judges. So, online participants will be back with our next and the last team. Thank you so much. Hello, team Brogrammers. Now it's your time to present, and you'll be given strictly 8 minutes to present. I'll be giving a reminder of 4 minutes and 1 minute left. So, you go ahead and best of luck.
Thank you. Afan, can you present the screen?
Yes, yes, it is present.
I just wanted to make sure, am I audible? Am I audible?
Yes.
Yeah, thank you very much. Okay, I'll start. They were the most difficult 6 hours of Meenakshi Sharma's life. The MNC executives scrambled to arrange blood needed for her boy's complex surgery at a prominent hospital in Delhi. Given her reach and connection, she somehow managed supplies from a private blood bank in the city in the nick of time. What about the common man of India, who isn't as fortunate as Sharma's son? आप खून तो दे रहे होते हो किसी की जान बचाने के लिए, लेकिन क्या उससे किसी की जान बच रही होती है या कोई उससे पैसा कमा रहा होता है? So here we are today, team programmers with our project Ek Rakt, where we are trying to improvise India's blood management network powered by technology. Afan, can you go to the next slide? India has the world's largest shortage of blood, with all states together battling a huge shortfall of 41 million units and a demand outstripping supply by over 400%. Do you know last year 12,000 people died due to scarcity of blood? Why is this shortage happening? Yes, you guessed it right. Lack of seamless structure of blood management system, and not just that. We have all been through this deadly pandemic, and we all know the extraordinary demand for blood and blood products have been yet another consequence of this COVID-19. So here we are trying to solve this problem by mapping the surplus to the scarce. I'm very sure you might also have heard the story of blood scams. If not heard, you can also you can right away Google and see it. These scams occurring in the hospital as well as with the people. When we were doing the research and going through the scams, we saw a news articles where a girl from a Delhi wanted blood for her grandfather. The doctor said the blood isn't available in the hospital. Someone in the hospital whispered her and said, I might know someone who can give you the blood. There are various scams too. Now I would like Pallavi to explain the other problems we are trying to solve.
Okay, the other problem is lack of technological direction. There is no current technology in this system present in India that monitors the entire blood management and donation network. After donation, the donors have no idea where the blood that they have donated is actually used for a good cause or not. What happens after the blood is inspected and transported to the hospital? It is really used by patient in need or just sold in black. Through our solution, the donors will know about the status of blood in the chain, and each and every donor's information will be recorded through blockchain, and the entire supply chain of your blood, starting from the point when you donate your blood to when the patient receives it. Everything is intact, thus maintaining transparency and immutability. Then last one is blood verification, a maze. According to the National AIDS Control Organization, poor blood transfusion infected 2,234 patients with HIV in the last few months, and more than 14,000 illness due to impure blood transfer. We are trying to create a system which is reliable, secured, and scalable, where the patient gets safe blood and infected blood does not enter the system in any way. These are the problems we are trying to solve, and now I would like to Mansi to take the stand.
Yeah, thank you, Pallavi. So this is how basically a system design looks like. We have three entities: the donor, the blood bank, and the hospital, and all of them are connected using the blockchain network. So yeah, this is just a gist, but we can move on to the next slide where we'll talk more about the exact algorithms that we've used in our project. Afan, next slide, please. Yeah, so over here, the first one is the blood transfer, which basically tells us when the point from where the hospital requests the particular blood group from the blood bank, and how that request is networked to that particular blood bank
which is calculated based on the deciding factor. So which is basically proportional to the distance between the hospital and the donor blood bank, or since we have also considered the case where the two blood banks can exchange blood, and the deciding factor is also inversely proportional to the amount of blood that is present in that particular blood bank. So this is just an overview. Now we'll move on to the demo of our project, and I would like Afan to take over.
So now, as we have created a portal and we have connected it to the Polygon and deployed it in it. So when we have deployed, we have get a contract address. By this contract address, we get to know how many blocks have been initiated and created as the form of the assets in our blockchain. As by the timestamp, we can see it has been created yesterday. So and also we have used a Netlify to deploy our network. That here in this website we have deployed our blockchain. So as we are using the Polygon, sometime it takes 4 to 5 seconds for each transaction to happen. So we have pre-recorded that video, and this is that video. So as you can see from the clicks, first it will go to login as a blood bank. So in login as a blood bank, we have created our own Aadhaar API, uh, our own email associated with password, and also giving a two-factor authentication with the blood bank. So it should match the proper email ID that is mapped to the proper wallet address. So here we are selecting the blood bank one, and we are logging in. So when we are logged in, we will see a dashboard which will give the blood bank names, the type of the blood that have, and the donation history. And in this donation history is give the overview of what is the ID, what is the batch number, and if it is verified or not verified. If it is verified as a safe, then only the hospital can access it. So the blood ID and the batch number, this is the number of these are the two elements which is provided by the government, and it is available in the blood units. And the Aadhaar number, we have created our own Aadhaar API, and by giving that Aadhaar number, we will get the details of the patient who is donating. So now here the transaction have been happened, and here you can see the transaction is in the Matic, which is in the Polygon network. And when the transaction has happened, as you can see the donation have been added with O positive, but it is not tested. Now after the testing has done, we get to know that if it is a safe or unsafe. If in both the conditions, we will get an email by the email JS about getting the latest update, and here also the transaction will happen. As we are when we change its status to safe, then when the hospital requests the blood by using the deciding factor, they can access it. Now the later on part with the hospital will be explained by Mansi.
Yeah. So now since the donor and blood bank have completed their work, we have the hospital in picture. Hospital also has a wallet address. They can log in through their email and password. And as soon as they log in, yeah, so if they have a patient who needs the blood, say A positive, they'll request that blood, and they'll also put in the patient's Aadhaar address. This is just for accountability and making sure that the hospital is not making the wrong use of blood. So after clicking on searching, as I had showed you earlier, the algorithm that we've implemented, which is the deciding factor, it helps us get the list of all the blood banks in ascending order based on that factor, and then whichever one is the first, the request is routed to that blood bank. Then here you can also see that so after getting that, we see that Vijay blood bank is the nearest, and based on the factor, we also have a view map option, so we can check where the blood bank exactly is based on, so it will help the hospital in the physical transportation. And we have a scan and check feature, so the QR code which was downloaded earlier and which is stuck on the actual physical blood packets is used here. So this is basically that QR code which is getting uploaded, and then we can check that with the hash which is generated now, like after scanning. So if both the hash are same, it means that it was valid. And we also have an option of download receipt, so the hospital can get the receipt basically for storage purpose to understand, okay, this was the blood bank from where we obtained the blood. And we also have a notification system, so every entity in the system, like the patient, hospital, and as well as the blood bank, all will get notified through email. Now the final part is where I, as a donor, can come. I can enter my Aadhaar number and my blood ID that is unique, and I can check the entire timeline of where my blood was initially. Like it was not verified, and it was at the Vijay Blood Bank. Then it was sent to the inspection center. It was tested safe, and finally it was given to the Ankur Multi Speciality Hospital. So this is how we maintain transparency of a system. Now I would like to hand it over to Vivek.
Yeah, thank you very much. So this was the thing we built, and we are actually definitely open to the feedbacks. And we actually want to implement this on a larger scale, and that's why we really want to work on the feedback. And this is something, this is not just a hackathon for us. This is something we really want to build, and we are open to questions and feedbacks.
Just a second, I need to add one more point. Here, as Mansi said, for the QR code, why we are using a QR code? Because as initially when I am a donor, I donated a blood where the test verification has been done of that blood. But when hospital takes that blood to the patient do that verification again. So it is time consuming and also the cost consuming also. So what we have done, when the QR code is scanned again on the hospital end, it can, by the blockchain, it can verify that this is the same blood that have been requested. And in this QR code, it uses a SHA-256 so that all the identity is been secured. That's all. We are open to questions.
So two questions here. One is why blood? Because this can be used across multiple industries, right? It's basically tracking on the blockchain. So why specifically focus on blood? And the second is, wouldn't this be possible with the regular database? What is the benefit of having a blockchain here? Why not just have a database with strong encryption?
Yeah, I would like to take the first question. So initially we are actually planning for this blood only because we have seen a numerous number of scams, right? And given the condition that we had only 24 hours to build, if we wanted to add for organ trafficking, or if you wanted to add for let's say some other things, right? So in that way, we also thought of the time constraint because we had to add more components. That is the first thing. And Afan, would you like to take the second question?
Yes, as for the centralized database, there can be encryption, but there can be a way that it can be hacked, because in an encryption, if a key has been compromised, then it can easily break that encryption. But in the blockchain, it is not possible, because as a way of authentication, we are providing two-factor authentication with the wallet address. And if the wallet, if any hacker knows the email ID or password, but the wallet address is anyways the unique, it is only associated to that blood bank only. And there is a one more point, like if you use any centralized server has a central authority that manages the server. But in the blockchain, there is no centralized authority who can access, manage, or manipulate the blockchain.
So basically, yeah, we also have, if your relative, suppose you are a doctor, right? And if your relative is, going through something and you need blood, right? So there's high probability that you will look after, someone who is actually in more emergency situation. You'll look after that, right? And you'll try to manipulate, you will try to hamper, or you'll try to do some kind of corruption, right? So that is also, not possible here because of the blockchain. And yeah, Mansi, would you like to add something?
Yep. So like every time a donor comes, so a new entry is created on the chain. So even if you donate your blood, like people who are not really educated, so they don't know, they just donate the blood and they don't know where it goes. But in our case, everything is getting recorded, so there's no chance that you can delete it. So everything is on chain, and there's no central authority, as mentioned by Afan. So it gives us an edge.
So
how did, yeah, go ahead.
yeah, sorry. So just to understand, forgive me if I missed it in your presentation. When you're storing it on chain, have you created an altcoin or ERC21 token for this? Is it a ERC721 token? Like, is it a NFT per blood bag, which marks it as unique? How is it really stored on chain again?
It is not has created a different token, but we have to store it on a blockchain. We are creating a form of an asset for uniquely identified, And for the unique identification, we are using the same unique ID number which is provided by the government, which is available in Blood ID.
So you're building this on which chain again?
With Polygon.
Polygon, right? So is this an NFT
No, it is.
is this an ERC 721 token? Is it an ERC 21 token regular?
No, it is not an NFT token.
Okay.
And
How do
for
you differentiate? How do you differentiate two bags of blood?
two different bag of blood.
Yeah.
For that, we are using the every blood has a unique ID and batch ID. We are using that to differentiate
So
it.
in the metadata, like with the payload, you would ideally put the unique identifier in the coin.
Yes.
And it is generated.
Yes.
Also, so if you see the pouch that government gives, it has already a batch ID and some other ID which will have, and we are also taking the details, Aadhaar details of the user, right, the one who is actually donating, and the timestamp, and we are actually making hash out of it, and then we are generating a QR code.
And sir.
So basically, this. Yeah, go ahead, Afan.
And also, sir, like if we take this application to a deployment and actual live use case, as initially have showed, we have deployed it to Netlify. So if you have a MetaMask account with connected with Matic, Polygon, and your wallet address, if we take Mansi and Pallavi, they are owners of two blood bank. We are registered it in it, and
Got
Vivek is the owner of hospital. If we do that, and they can use that netlify.com, and they can use it into the live scenario also.
Okay, got it. Sorry, Harshal, you were asking something.
Yeah, how do you prevent forgery of the initial donor's data? Like, what if I give the blood, but it goes in Vatsal's name?
Correct. Yeah, we actually have thought of this. So suppose, so you are just saying the fraud where actually we have been through a lot of news. So you are saying the campsite is the one which is doing the fraud, right? Not the user, right?
Yeah.
Yeah. So that is why I actually indicated that where does your blood goes, right? So as soon as you go on the campsite, so you just donate your blood, right? When you donate the blood, you'll get an ID, right? Ticket ID and your Aadhaar number. So if you go to the portal, you have a access, right? So at the same time, if it is real one, what will happen? They'll actually create a contract. They'll make a smart contract. They'll register the user, right? And they'll get a number, right? A blood ID number, basically tracking number, and a Aadhaar number, right? So you just go ahead to the portal. You don't have to log in, or you don't have to register anything. You just go to the portal, write your Aadhaar number and your number which is actually generated, given by the system, and just put it, and you'll get the tracking of it, right? So you'll get to the portal ki hamara blood kahan pe hai, and if it is not there, that means these people are doing scam, right? And consider you have been there, right? आप blood donate करने जा रहे हो, and you get to know कि भाई यहाँ पे scam हो रहा है, right? यहाँ पे इन लोग blood कहीं और लेके जा रहे हैं. So what you'll do, ठीक है, आपका blood तो चले गया, you can't do anything, right? But I know because you are a good person, आपने blood donate किया है. What you'll do, you'll make sure कि बाकी और कोई यहाँ पे आके दे नहीं, right? So that is why we actually implemented that tracking वाला part.
Cool. I think no questions from us beyond this. Thank you so much.
I just had last point to say. So this was actually an offline hackathon, after 2 years, and we are very lucky and we are very fortunate that we actually, went ahead and attended the offline hackathon. So I would just like to thank you, the KJSCE CodeCell. It was amazing. Hum to aisa, it was a memory for us. We came after, we are currently in final year, leaving Mansi. And it was a big memory for us. It was a reunion for us actually, and we enjoyed a lot. And we would also like to say we made a good connects, and this was, and they have organized it also really well. So just wanted to thank you the team, and thank you also the judges, taking out time from your offices and coming here. And at the last, we also want to take this project further. We want to take this project because I believe this is something which can actually solve good problems. So we would also be requiring some kind of mentorship, or whatever feedback or help which we can get. We would love to connect with you all.
Yeah, exactly.
Yeah.
Thank you so much, guys.
Thank you, guys. Thank you, everyone.
Thank you so much, team, and we really appreciate your words. And now we will have the judging, so you guys can leave. And the next time we will be we will be outing the results. So stay tuned on the live stream. We'll be outing the results in few minutes. Thank you so much.
Definitely.